Today I'm going to talk about section 5.2, which is the law of cosines. So if a triangle ABC is an oblique triangle with sides little a, little b, and little c, and angles alpha, beta, and gamma, then the following are true. A squared is equal to b squared plus c squared minus 2bc cosine of alpha. B squared is equal to a squared plus c squared minus 2ac times cosine of beta. And c squared is equal to a squared plus b squared minus 2ab cosine of gamma. Hopefully you can see there's a couple of little patterns there. All right, so that can help you memorize these. So for example, when we're solving for A, we're dealing with the angle alpha. When we're solving for B, we're dealing with the angle beta. And when we're solving for C, we're dealing with the angle gamma. Right? There's a couple of different patterns there. Hopefully you can see them. So let's practice these law of cosines with an example. So given that A is equal to 3.1 and B is equal to 2.9 and gamma is equal to 121.3 degrees, we want to solve the triangle. Right, so I drew here an oblique triangle. And since gamma is 121.3 degrees, I'm going to choose this spot here for gamma because the other angles are going to be acute. So this is definitely an acute one. This is definitely an acute. So this is going to be my angle gamma, which is 121.3 degrees. And the length opposite of gamma is going to be my little c. So this is little c here. Right, and the other angles, it doesn't actually matter where we place them, so I'm just going to place alpha there and beta there. So we're going to be looking for these angles as well. And the length opposite of alpha is little a, which is 3.1, and the length opposite of beta is little b, which is 2.9. All right, so can we use the law of cosines right now? All right, so again, we have to find a couple of different things. So we need to find alpha, we need to find beta, and we need to find little c. Right, so let's focus on what we can actually find. So we have little a, we have little b, and we have gamma. If we look back at the law of cosines, the third formula here is the one that we're going to have to use because again, we have a, we have b, and we have gamma. All the other ones, we're going to have to know what C is, and we don't know what C is yet. So let's use the third one. So we're going to find C first. So C squared is equal to A squared, which is 3.1 squared, plus 2.9 squared, minus 2 times little a times little b, times cosine of gamma, which is 121.3 degrees. So you could do this slowly here, right? Or you can just put it all at once on your calculator. And again, my calculator gives me the value for c squared as 27.36. And again, to just find little c, we have to take the square root of both sides, and we're only going to take the positive of the square roots because we're looking for a length here. And so little c ends up being 5.2. Awesome. So we found little c, 5.2. And now we have to find alpha and beta. Now that we have little c, we have more possibilities. So let's find alpha. All right, and so in order for us to find alpha, we're going to have to use the first formula. we have a squared is equal to b squared plus c squared minus 2bc cosine of alpha. And again, we could solve for cosine of alpha right now and plug everything in, or just plug all the values of a, b, and c, and then solve for cosine of alpha, and then find alpha. So it just depends on what's more intuitive to you. So I think what I'm going to do is I'm going to solve for cosine of alpha first, and then deal with plugging in the values. So I'm going to isolate cosine of alpha, and so I'm going to have a squared minus b squared minus c squared is equal to negative 2bc cosine of alpha. And now I'm going to divide both sides by negative 2bc, and I get that cosine of alpha is equal to a squared minus b squared minus c squared all over negative 2bc. And now at this point, I plug in all of my values and then take the inverse to find alpha. I plug in all my values. For little a, we have 3.1, that's being squared, minus little b, which is 2.9, that's being squared, minus little c, which is 5.2 squared. All divided by negative 2 times 2.9 times 5.2. So let's plug that into our little calculator. With our calculator, we get that cosine of alpha is equal to 0.8568. I'm going to round to 4 decimal points. And so if we take cosine inverse of that value, we would get our alpha. And so we're doing alpha is equal to cosine inverse of 0.8568, which gives us 31.0 degrees. All right, so now we have alpha, which is 31, oh, that looks terrible, which is 31.0 degrees. And the way we find beta is, again, just by doing the property that alpha plus beta plus gamma is equal to 180 degrees. And again, using this property, we get that beta is equal to 27.7 degrees. Let's try a different problem. So second problem, a solar panel with a width of 1.2 meters is positioned on a flat roof. What is the angle of elevation alpha of the solar panel? Round to the nearest tenth of a degree. Alright, so here we're looking for alpha. Because we're looking for alpha, we're going to be using the first equation, which states a squared is equal to b squared plus c squared minus 2bc times cosine of alpha. So it's going to be very similar to the previous example that we did. And so if this angle is alpha, then the length opposite of alpha is going to be little a. So little a is equal to 0.4. And the other sides don't matter. And actually, the b and c are going to be the same anyway. And again, it doesn't actually matter. So b is going to be 1.2 and little c is going to be 1.2. So again, it's up to you if you want to solve for cosine of alpha first and then plug in the values, or plug in the values and solve for cosine of alpha. It's up to you. I like to not deal with the numbers at the beginning, so I'm going to solve for cosine of alpha. So we have a squared minus b squared minus c squared is equal to negative 2bc cosine of alpha. And we have cosine of alpha is equal to a squared minus b squared minus c squared all over negative 2bc. Now I'm going to plug everything in. So we have cosine of alpha is equal to 0.4 squared minus 1.2 squared minus 1.2 squared all over negative 2 times 1.2 times 1.2. Let's plug that into our little calculator to get cosine of alpha. Our calculator gives us that this is cosine of alpha is equal to 0.94. There's a couple of 4s there, but I'm just going to leave it there. And so if we take the inverse to actually find cosine, to actually find alpha, we get that alpha is equal to 19.2 degrees. And so we found that angle of elevation alpha for those solar panels, 19.2 degrees. Another topic that I want to talk about is the triangle inequality. And so not you're not going to be able to create a triangle all the time, right? And so you have to be very careful. Right, so to determine a triangle with 3 given sides, SSS, the sum of the lengths of any two must be greater than the length of the third side. And so suppose that this is little a, little b, and little c here. Right? In order for us to actually create a triangle, again, any two sides must be greater than the third side. And so if we do a plus b, the sum of those has to be greater than little c. And again, it's any two. And so a plus b has to be greater than little c, or a plus c has to be greater than little b, and little b plus little c has to be greater than little a. The moment that one of these inequalities is broken, we cannot create a triangle. So let's actually try the examples down here. Determine the number of triangles with the given parts. So let's start with A. We're told that A is equal to 3, B is equal to 4, and C is equal to 7. So let's see, if we have an actual triangle, can we even create a triangle with these lengths? And so my longest side here is 7, my smallest one is 3, and my B is 4. And so if I do A plus B, is that going to be greater than C? So let's plug it in. We have 3 plus 4. Is that greater than 7? Nope, because here 7 is not greater than 7. And so this fails the triangle inequality, which means that we cannot create a triangle with these given sides. Let's talk about B. So B tells us that C is equal to 10, that alpha is equal to 40 degrees, that beta is equal to 60 degrees, and that gamma is equal to 90 degrees. So we have a right triangle, so let me draw that out. And so that's my 90, that's going to be my gamma, and then one of these is 40, and again, not drawn to scale, and one of these is 60 degrees. So here is my alpha, here's my beta, and here's my gamma. And so the length opposite of my gamma would be 10. But now, can I even have this triangle that I drew? Okay, so here we have 3 different angles. Remember, all the angles in a triangle have to sum up to 180 degrees. Do these sum up to 180 degrees? So let's see. So again, remember alpha plus beta plus gamma have to add up to 180 degrees in order for us to actually make a triangle. Here, my alpha is 40 degrees, my beta is 60 degrees, and my gamma is 90 degrees. This actually sums up to 190 degrees, which is not 180. So again, we cannot make a triangle here. Again, because the sum of my angles is more than 180 degrees. The next topic that I want to talk about is the length of a chord. And so if a chord of length A subtends a central angle alpha in a circle of radius r, then we're going to have that little a is equal to r times the square root of 2 minus 2 cosine of alpha. And now we'll prove that right now. So let's add a little shape here. So here is, again, we're working with the circle, so there's my circle. We know that we have a central angle. And that's a terrible line. Here's my, oh, another terrible line. Okay, maybe I'll just be able to, I don't know why this is not working out for me. Alright, thanks to the mouse, that worked out. And again, we are gonna create a chord. So here's the chord. Alright, that looks good. Perfect. Alright, and so we have our angle alpha, which is our central angle. Alright, and notice that it says that the circle has radius r. So that means that this length here is r, this length here is r. And since the central angle is alpha, that means that this length here, the length of the chord, is going to be little a. And so that's what this formula is talking about. It's finding the length of the chord, right? Which here in the formula says that little a is equal to r, the square root of 2 minus 2 cosine of alpha. So let's actually prove this. Let's actually find what a is. And so in order for us to find a, then we could use the law of cosines. And so we have that a squared is equal to b squared plus c squared minus 2bc cosine of alpha. But notice that my b and my c are both r. And so we have a squared is equal to r squared plus r squared minus 2r times r cosine of alpha. And so I'm going to combine like terms a little bit and simplify. So we have r squared plus r squared gives us 2r squared, and then minus 2r squared cosine of alpha. Notice that this term and this term, they have a common factor of r squared. And so I'm going to take that out. And so I get a squared is equal to r squared 2 minus 2 cosine of alpha. Now remember, we want just a, not a squared. So we can take the square root of both sides, and we're only going to keep the positive of the square root because, again, we're talking about a length here. And so we're going to take the square root of r squared, 2 minus 2 cosine of alpha. And by rules of radicals, we get r times the square root of 2 minus 2 cosine of alpha, which is the original formula that we had here. Alright, so hopefully you guys like that little proof of the length of a chord. Let's use it. So now that we've proved it, okay, let's actually use it on an example for here. So a regular pentagon in a circle of radius 6 inches. So we have a regular pentagon in a circle of radius 6 inches. What is the length of the side of the pentagon to the nearest tenth of an inch? I actually forgot to mention that this regular pentagon is inscribed in a circle. So I forgot to include that it's inscribed in a circle. So let me just draw this out. And it's gonna, again, it's gonna be a little bit funny looking, but hopefully it, you know what, I'm gonna use my shapes. So here is my pentagon inscribed in a circle. So again, it tells us that the radius of the circle is 6 inches. What they're asking us to find is the length of a side of a pentagon to the nearest tenth of an inch. So they're asking us to find one of these lengths. And again, since it's a pentagon, all of these lengths are going to be the same. Okay. Well, notice that the length of a side of a pentagon looks like a chord. And so if we actually, again, here's the center of my circle. If I draw a line from the center to that end, and from the center to this end, notice that, again, this looks like we've just created a central angle. Let's call that central, let's call that central angle alpha. So this central angle is alpha. Remember that the radius of a circle is 6 inches. So that means that this length here is 6 inches. That's my r is equal to 6. So again, this is my radius from the center to the end of my circle. And again, this one is also r is equal to 6 from the center to the end of my circle. And so what we're looking for here is the length of a side of the pentagon, which is my little a. So I'm looking for this length, little a. And we just talked about the length of a chord. That's exactly what we did earlier. Okay, the little proof that we did was for finding the length of a chord. And so the formula tells us that a, the length of a chord, is equal to r, the square root of 2 minus 2 cosine of alpha. And we have everything. We know alpha, we know r. Oh, we don't know alpha. But we can actually figure it out. So notice that again, this pentagon cuts our circle into 5 equal pieces. We know how many degrees are around one circle. And so around the circle here, so the whole circle is 360 degrees. But notice that we broke it into 5 equal parts because of the pentagon. So alpha here is one of the 5 equal parts. And so all we have to do is do 360 degrees divided by 5, and that's going to give us that alpha is actually 72 degrees. Okay, so all of these angles here that are created with the pentagon, these central angles, they're going to be 72 degrees. And so we can plug everything into this formula here. So little a, which is what we're looking for, is equal to 6 times the square root of 2 minus 2 times cosine of 72 degrees. So if we plug all this into our calculator, we get that a is approximately 7.1 meters. Oh, this is in inches. So 7.1 inches.